what happens when the conditional statement is true and its converse is also true? Well, then we can combine it into one statement called a biconditional statement. And it's also referred to as the if and only if statement. Alright, so let's see what it looks like if we were to use symbols. We know that for a conditional, we draw it out like this. Okay, so this is for the conditional. And for the converse, it's written out like this. So for a biconditional, it will be written out like this. So you have the arrow pointing in both directions. Okay, so this is the way you write the biconditional. Alright, so now let's take a look at this example. We have segment AB, and M is the midpoint of segment AB. So we can write it as a conditional like this here. If M is the midpoint of segment AB, then AM is equal to MB. So that would be the conditional statement. So why don't you pause the video and think of what the converse will look like. Now let's check to see if you got the right answer. If you wrote out for the converse, if AM is equal to MB, then M is the midpoint of a segment AB, then you got it right. Okay, so since we know that the conditional is true and its converse is also true, we can combine both statements into one statement called the biconditional. And we know that we have to use the phrase if and only if. So the biconditional will be M is the midpoint of segment AB if and only if AM is equal to MB. Alright, so here's a quick review on what makes a good definition. You can actually show a statement is not a good definition by looking for a counterexample. Alright, so I have an example here. A segment is part of a line. So a counterexample for this is, well, it doesn't necessarily be a segment. It could be a ray. A ray would be the counterexample. A ray is also part of a line. So this is not a good definition. So we can put an X here. Alright, so we've reached the end and we're done and we're happy.